my show. Again, I'm going off some electronics today. Just before I start talking electronics, a big congratulations to the people at IM and at NASA for getting the first moon landing in 50 years for US. It's quite an achievement. Everyone else has had little hiccups and things that didn't quite work properly, and this one was a success. So congratulations to the whole team for getting a successful landing. Okay, so today I'm going after someone who's built yet another crazy looking circuit, and we're just going to work our way through what they put up there as their basically as their schematic, and we'll pull it apart. Okay, you'll have to pardon any noise in the background. There are people here cutting wood and doing some work at my house this morning. Saturday morning and they're out working. Well, I'm going to be paying for that one. Okay, on with the show. Let's have a look. Now, first mistake he's made is he's just written exactly what's written on that capacitor. And this is not the correct value. It's not a 400V farad at all. So this is not correct. It's misunderstood what this is about. The 225, the three numbers, I'll go into those a bit later and explain what they mean. But this is a typical mistake. Police do not know the electronics and they start constructing things. Okay, 1 meg's a pretty hefty component. Actual fact, they're not 1 meg. Color codes are wrong, so there's a second mistake. Now, they've introduced 3 more components onto the screen here, but you have a close look. They don't tell us what this is, or this, and they don't really tell us anything about this either. Okay, so now they're telling us this thing will take 220 amp. 220 volts, but what does it actually say here? It does say AC, not amps. Now, what I really enjoy is the claim right there. Watch this carefully. They're very clever because they took that, they just transitioned straight on to the commercials at the end. This is really interesting. How on earth did they come to the conclusion that would do one of all of these? This componentry just doesn't seem to fit. So let's go and have a really good look at what we've got coming. I do have to fix one little thing up. There's a white component. Every time you open and close something, you've got to open and close it again. Good go. And this is the schematic we're going of that video. Let's go digging. I think it's kind of fun to dig into these. Alright, first thing we notice, 220 volts input on this side. Where is the fuse? Where's the filtering? Where's the safety for it? None whatsoever. I've worked out that one has to be Zener for this circuit to do as advertised, but basically your biggest problem is going to be if either of these capacitors C1 or C2 go short, you have mains pretty much go straight through it. Your capacitor, which they gave no indication of size, might be much good. Now, just very quickly, so let's have a look at this. You have 220 volts, and you've got a 2 mega ohm, 2 mega ohms of series resistance. Get a value for it's about 10 milliamps. Probably being a bit generous, it's actually, no, actually it's about 0.1 of a milliamp. Not a very useful power supply. That's pretty much what you would draw. Now, I haven't taken account of the capacitors yet. The capacitors were the 2.2 microfarad. So these will allow pulses of energy to get through, and he's only halfway rectified here. In terms of what that's going to do, so the pen for this, basically what comes in here is just a pure sine wave. Goes through these, it's no longer as big. He's relying on this to cut down the current that flows in this direction when it breaks down. But what he hasn't accounted for is that when the phase changed direction, he's now got a short, which is why he had to put that diode in. So this will only produce when it's running this direction, where you've got positive and negative this path. And when you do that, you'll only get current flows around here as well. This thing will give you a 0.7 volt drop. Okay. By the way, I can't see the chat at the moment. I'll see if I can find the chat window. There it is. Morning, Peter. I can see you there on the chat, so I know that's working. Thanks for participating, Peter. Thanks for doing that, Pete. That's really appreciated. But basically, yeah, this is what we've got. We've now got a reasonable run out of this. It will produce percolates in a diode, it does, but I've got a funny feeling this one will let the smoke out of this component and probably end up killing that component, because all it's doing is building up charge. It will build it up until it does reach somewhere towards that peak. Because if you have the current running consistently or constantly in each pulse, even with halfway rectifier there, this component's been exposed to a position where it will break down both directions and will probably fail. Even though he's cut the amperage down to 0.1 milliamp, this will not provide you with much power on this side. You ask it for too much power, it will simply drain C3 and that will be the end of it. This circuit will stop functioning. Okay, we know we see this quite a bit, but they just keep building these things up and they don't seem to have a problem doing this. I believe that the circuit is very dangerous. You're going to get electrocuted come in contact with this. If C1 and C2 break down, you will have lanes pretty much go straight through this circuit in both directions. So let me go back to, now I've been through this, it's all good. Right, so there are no further technical issues. I think the sound has been looking and sounding fairly decent, something which we haven't had for a little while. And the background track that was playing isn't playing anymore. Not to worry. Yeah, I had OBS issues last night. It actually broke down on me, and then I ended up with things not quite where it's supposed to be. The camera wouldn't work. Mobile phone was red hot last night, and yeah, it was kind of fun watching everything just stop very suddenly. In any case, as for the circuit, guys, please stop producing these. They're just going to hurt somebody. You might not think you're liable, but in some countries, putting that kind of material up, even without any warnings, is a good indicator that you could be liable. Please stop doing it. Please start thinking about other people's safety. It's great to see you're fiddling with electronics, but you really do not have the knowledge to do this safely. It's bad engineering, and longer term, I don't believe that you'll bank a good engineer or electronics tech at best. Good luck, guys. Sorry if I sound so critical, but as long as I keep seeing this, I'm going to be critical about the simple reason that will hurt somebody. Kid sees this and starts playing with it, who knows what damage you're going to do. Righto, guys, I'm done. I'm out. Everyone enjoy the weekend, because that's what it is for me. It's the weekend.